Hi, welcome. I'm gonna go over really quickly how to navigate the Google Classroom because a lot of you are still having a hard time with navigation. Anyways, when you guys go into your Google Classroom, right here in this section, you should be able to see essentially all your assignments that are due. This assignment is due at 11:59 p.m., basically midnight. But make sure you turn it in on time for your attendance because it's really, I guess, a handful if you guys turn in really late and I can't change your attendance right away. Anyways, your class, go to Classwork if you need to, but it's under asynchronous work Wednesday, and it's called Classwork dash 09/16/2020. That's your assignment. Anyways, in the stream, you could also access it on this section. Anyways, that's a little bit about your Google Classroom. I just don't want to spend too much time on it. I do review it often with you guys. All right, so I want to give you a quick review before you guys start your assignment. So that's why I posted this video inside your assignment. All right, so probability. I basically want to make sure you guys understand what it means. So probability means chance of something happening. I'll repeat it again. Probability means chance of something happening. So at this time, please engage and repeat it with me in one, two, and three. Probability means chance of something happening. All right. So now that we got that down, I hope you understand what it means. So in the first few weeks, we talked about probability of 0 and probability of 1. And probability of 0 means something cannot and will not happen. Probability of 1 means it will definitely happen. And an example that I like to use is, what is the probability that the grass in the picture will turn orange if you say hocus pocus? So what is the probability that this will change to orange after I say hocus pocus? And let me say that to the picture. Hocus pocus. All right, I hope you were able to kind of understand that this scenario or this event is a probability of 0. It cannot happen and it won't happen. So it's probability of 0. Another quick example. The probability that $10 will have less value than $20. So $10 being less than 20. What's the probability of that? So that's the probability of 1. It's gonna always have a less value. It cannot gain any more value than $20. $10 is always less. Okay, so let's go ahead and go and look at the equation. So after we learned that, we learned about that probability kind of basically existed between 0 and 1. And that's why we need this equation, because we need to make those fractions. So we use this fraction because we're going to get fractions we're going to use this equation because we're going to get values between 0 and 1 in fraction form. The equation reads probability of a favorable outcome equals the number of favorable outcomes divided by the total possible outcomes. So I'm going to go ahead and repeat that just really quick. Let me go back. I don't know why I went. Oh. All right, this equation, just really quick again. It is the probability of a favorable outcome is equal to the number of favorable outcomes divided by the total possible outcomes. Okay, that's the equation. So I'm going to do an example using this equation. All right, what is the probability of not landing on A? I'll read it one more time. What is the probability of not landing on A? Just a friendly reminder, I always ask you guys to circle or annotate important information and always find out what the question's asking you. So I hope you spend some time right now finding out what the question's asking you. And it's very clear because it's kind of straightforward, this problem. It's asking you what the probability is of not landing on A. Not. We're looking at the not part. So we don't not want to land on A's. So anyways, let me go ahead and write the equation for probability. So we're looking for probability not, let me actually write it in red because that should be in red, not A. Let me go back to purple really quick. So not A, and that's equal to a fraction. The numerator, that's the number of favorable outcomes. So right now we're looking for the favorable outcome of not A. So how many are not A's for the numerator? And let's go ahead and count them. That's 1, 2, 3, 4, 5, 6. Not A. We have a total of 6. That's our numerator. Okay, we're going to look at the denominator. This is the denominator, the bottom number. The total possible outcomes. So how many total possible outcomes do we have? On the wheel, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8. I did teach you guys to just count them and just write the total before you even do anything. I'm just kind of speeding up because I don't have a lot of time. Anyways, this is your fraction for the probability of not A. I also taught you guys how to convert this fraction to a decimal. I'm gonna walk you really quickly how to do that right now. So on your tab, on the little plus sign, click the tab button. You can always drag these around, by the way. You always want to go to Google Calculator, or if you have your own calculator, you could use that too. Anyways, going back to this problem, it was a fraction of 6 over 8. I'm going to go ahead and convert this to a decimal. So P naught A was equal to 2 over, oh no, it's not 2 over 8. It is, let me go back. It was 6 over 8. So I'm going to write that down right now. So 6 over 8. I'm going to convert this to a decimal. So it's very simple to convert a fraction to a decimal with a calculator. You always start with the top number. The top number for this probability fraction is 6. Now remember that this line right here, I'm going to use red to emphasize it. This line represents division. So you're going to go ahead and do 6 divided by the number 8. And then you click enter or equals. This fraction turns out to equal 0.75. All right, now we're going to go ahead and talk about what happens when your decimal is very big. So I'm going to give you an example where your decimal repeats or is very large. So let's say we did a probability problem of red, and that was equal to 1 over 6. So let's find out what we do in that scenario. So we're going to do 1 divided by 6, click enter. And this fraction, the 1 over 6, is equal to this long decimal. I told you guys in class that don't worry about rounding and just count basically the tens place. Look at the hundreds place, and then everything else just scribble out and ignore it. So this is equal to 0.16, and that will be your answer if you need to type it in or you need to find it. Anyways, let me go to the next part of your I guess your review. So the next part of your review was essentially you're looking at experimental probability now. So I'm gonna kind of go over that. So after that, we learned about converting decimals and using the fraction. We talked about some other new subject, which was experimental probability. And this one is a little bit tricky because I did a bad job for periods 2 and 3, but everybody else I kind of taught it really well. Uh, anyways, so probability, the one we've been doing over and over again using this equation, was based on pure math. It was based on math. It's considered hypothetical. That means if it, in the perfect world, we should expect this. This is sort of like your hypothesis. This is something that you should expect. Anyways, we then introduced the idea of the experimental probability, sort of like things that actually happen because it's real life is not perfect like the mathematical based equation. Anyways, this equation is very, very similar. You have a numerator. That's just the number of times the event occurs. So whatever you're looking for, you write the number of how many times it happened. Here's a quick example. So if we flip a coin 10 times and we land on heads 7 times, and we're trying to find the experimental, we should write a little e, by the way, of heads landing on the 11th time. So we're going to find the experimental probability of landing on heads on the 11th time. It turns out from just the experiment of 10 times, we landed on heads 7 times. So the numerator is 7 and the denominator is 10. I'll explain a little bit more better on this one when I talk about the actual experiment we did in class. But anyways, I just want to introduce I guess, the similarities and differences. Let me go ahead and go to this one. Anyways, in class, I kind of told a story that I faced two-face once, and we both agreed that the probability of landing on heads and tails should be 1/2. And if we convert that to a decimal, it should be 0.50. So we both had even chances of flipping it. Anyways, we flipped it once, and it seems like it landed on heads. We flipped it twice, and then landed on heads. And we flipped it 3 times, and then kept on landing on heads. So I asked myself, why is he always winning? It's not 50-50. That's what I thought. And then I said, well, hey, Two Face, go ahead and let me grab that coin and let me do an experiment. And let's actually find out if the experiment kind of agrees with the math part, the hypothetical or the hypothesis. So I actually did the experiment 100 times, but I first repeated the experiment 25 times. So, anyways, the first time I grabbed the coin, I flipped the coin 25 times. I flipped it 25 times. And within those 25 times, I recorded how many tails I saw and also how many heads I saw, and the total was just of 25 flips. Anyways, my hypothesis, once again, you guys should just remember it's 0.50, just represents 50% or 50. Anyways, I wanted to find out what the probability was going to be for the 26th flip, because if it flips on the 26th, it should be 50-50. Anyways, the probability of the experiment landing on tails, I wanted to check how much was that. So I did that one, and it should be a fraction again. It should be a fraction. And the fraction says uh, the probability of tails should equal the number of times the tails occurs divided by the total number of trials. So the numerator is the amount of how many tails happened. So how the number of times the event occurred was based off this chart, the data we collected. It's 14. And the bottom number in blue, it's the number of total trials. Be very, very careful. We're talking about the total, how many times I repeated the experiment, and that was 25. And if I divide this out into a decimal, I got 0.56. That is not equal to that. So I said, wait, I think I should investigate a little bit more, because this coin does not look fair. It should be equal to 0.50. And right now it's telling me that it prefers tails. And I'll show you why. Because if I look at the P experiment for the 26th, the probability of landing on heads for the 26th time, it actually equaled less than 50%, which meant that it favored tails, but for some reason, Two Face was always winning. Anyways, it was 0. I believe 44. So anyways, it means tails was preferred, but anyway, it should not be like that. It should be 50-50. So what I did, I basically repeated the experiment. Eventually I repeated it 100 times, and what I found out is every time I repeated the experiment, I found out tails and the probability of the experiment for heads for the next flip was getting very, very close to 0.50. And for the tails, the probability of the experiment, when I flip it 100 times, I saw tails 49 times. So the numerator is the number, once again, is the number of times the event occurs. So for the fraction of the tails one is, it starts with the numerator of 49, and that's going to be divided by, because it's a fraction, fraction is just division, divided by the number of trials. So how many trials did I do? I did 100. So the bottom number is 100. So if we divide this out, we got 0.49, which is very, very, very close to 0.50 compared to when we just did it for 25 times. we found out that the experiment for tails was way off. It was like 0.56. And basically, what this means is if you repeat an experiment for any type of game where you are flipping the coin, flipping the dice, or any type of probability, if you repeat the experiment over and over again, your probability for the experiment should match up and should kind of support your hypothesis. Anyways, that's a little bit of summary of the overview. So, in a nutshell, if you do an experiment over and over again, you will definitely prove your I guess your what was it called, your event or your type of game to be fair. Now, if it does contradict, it means if it does not prove it, then something's wrong. Perhaps you're getting cheated. Anyways, I'm gonna go ahead and go over your homework for Wednesday. I'm gonna go over your homework really quick. So I did paste both the pictures for the equations. Just be careful which one you use. You should be fine if you even mix them. Anyways, question 1 and question 2, those are old material. That's probability of 0 and probability of 1. Just be careful on the multiple choice. Read them carefully. Number 3, that's the old probability equation. That's the regular one. Number 4, that's old probability. You have to understand the equation to actually pick the correct image. Number 5, it's same. It's just review. Number 6 is also a little bit of review. Or actually, never mind. Number 5 and 6, that's not review. That's a little bit of your review with converting your fraction to decimals. So number 5, you might need to convert your probability equation to a decimal to be able to find your solution. Number 6, you might need to be able to convert this fraction to a decimal so you could compare it to this decimal. And anyway, 7, 8, 9, and 10 are all questions based off the experiment probability. It has a P with a little E in the bottom. So number 7 is asking you, a store sells towels for 4 different colors. The store clerk records the towels bought by 50, remember 50 customers. And based on the clerk's data, what's the probability of the next customer buying a pink towel? That's an experimental probability. Number 8, a mini M&M's bag contains 30 blue, 20 red, 15 green, 10 yellow, 15 orange, M&Ms. You pick the random M&M 10 times and return it every time based on your data that you collect. What is the experimental probability of picking yellow on the 11th trial? So you're looking for the experimental probability on the 11th trial for picking yellow. You're going to use the data collected. Number 9, it's very similar to number 8. You have to type in your decimal. Just really quickly, number 8 and 9, you have to type in the decimal. Number 10, you're kind of like either finding a way to improve your experiment. I hope you guys listen to how you can improve it. I'm not going to tell you how to improve it right now because you should have listened within the video. Anyways, if you definitely need support or help, reach out to me via email. Your homework is due Wednesday. If you turn it in late, it does not help me, it does not help you, because at the end of the day, you're just giving me a sort of a time constraint to even reach out to you, because I'll find out late that you don't understand it or whatever it may be. Anyways, I hope you have a good day. And if you need to contact me in my email, or if your dad or mom wants to contact me via Parent Square. Anyways, I hope you have a good day. Goodbye.